Alright, so we've looked at all the limaçons that we are going to look at, and now we are going to talk about these functions. Notice they're slightly different. We do not have a constant term that we are adding, and we do have a modified period. We're multiplying theta by 4. So I'm going to start the same way. I'm going to sketch this graph, but what I need to recognize is that since I'm modifying this period, I'm actually going to end up with 4 full periods between 0 and 2 pi. So go about setting up your axes however you want, but what I like to do is I like to set 4 theta equal to pi over 2, our normal nice increments like we used on all of the other problems we just did, right? We did 4 tick marks, each pi over 2 apart. So we're going to do the same thing here. We're going to say let 4 theta equal pi over 2, then divide by 4 to get theta equals pi over 8. This tells me that if I want to get those nice key values, each tick mark should be pi over 8. So I'm going to go ahead and create my axes to reflect that. Alright, so we got a lot of tick marks there. How many tick marks? Well, there should be 16 tick marks there. That 4 is giving us 4 full periods between 0 and 2 pi. We're taking a normal graph, we're multiplying theta by 4, so we're going through 4 times as quickly, which means if we look at the normal period, 2 pi, we're doing 4 full cycles in there. What does the 6 do? As always, the 6 is our amplitude. Whoa, whoa, whoa. So 6 and -6, and then 0 in the middle. And again, we're talking about r for the vertical and theta for the horizontal. So now let's sketch in this graph. We're dealing with a cosine graph. Cosine starts at its maximum value, so we're going to have that point. Then every single tick mark, it's going through a quarter of its cycle, which means it's going to those key points. So we can graph it in the same way we always have, just alternating back and forth between those values. Boom, 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 boom. And we're going to do that all the way through. Now, what I like to notice is that every single denominator there with 8 is getting a point on our horizontal axis. So I'm going to recognize that pattern, and I'm going to continue it through to the end. Now, if you look at the bottom, those minimum values happen every 4 tick marks. So I can continue that pattern as well. And I get all those bottom values, and the same at the top. Those top tick marks are happening every 4. So I can use that again to make this sketching of the graph a little bit easier. And I'm going to finish 2 pi right where I started at the top. Now I can sketch this curve in roughly. And this is very roughly. Not very pretty, but it tells us what we need to know. It's showing all 4 of those cycles between 0 and 2 pi, and it's going to allow us to use all of those values. So now let's transfer this to a polar curve. Now you might be thinking that you need to add all of the pi over 8 lines in there as well, like boom, 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 but actually if you think about it, we do not, because all of those pi over 8 values have an r value of 0, which means they're all just right at the pole, and so they don't do anything. So let's start as we always start. When theta is 0, our r value is 6, and we can plop our first point right there. There's our first point. Then where's our next point? Well, we go to the pole. So we're starting at 6, and if you look at our graph, our radius is decreasing. It's going from 6 down to 0. So it's going to get smaller each time. And by this point in graphing these, we've hopefully recognized that we're going to end up with that petal shape where it curves down, decreasing the radius, and then we're crossing that pole at pi over 8, and now we are increasing down to pi over 4, where our radius is getting more negative. So if we have a -6 value at pi over 4, that actually means we have positive 6 along 5 pi over 4. So 1, 2, 3, 4, 5, 6. Right there, right? Here's positive pi over 4, there's negative pi over 4, and we're going 6, so there we have that. And so our petal needs to curve down to that value, increasing in the negative, like that. So if you think about how we're actually angling across there to go from point to point, it can kind of help you determine the thickness of these petals as well. These are probably going to be kind of thin because we're going to have a smooth curve going through. All right, well, then at 3 pi over 8, we are starting to go back up now, so the negative is getting less and less, pulling us back up into the pole, and then we're going up to a maximum value of 6 at pi over 2. So I'm going to put my 6 at pi over 2, and I'm crossing my pole between there, so I'm going to continue down from this petal and curve up to that petal right there. That's pi over 2, and then I'm going down again, decreasing, crossing the pole at 5 pi over 8, and then hitting a negative 6 value at 3 pi over 4. So if I'm hitting negative 6 at 3 pi over 4, I am down here again along the 7 pi over 4 since I'm negative. So then this petal is going to swoop down, cross the pole, and curve out to that guy right there. So again, it's important to watch how this is actually drawn out rather than just sketching in the petals, thinking that you know how it's going to look, because the process is important for us. So then we go back to the pole, and then we hit a maximum value at pi. So at pi, we're over at 6. So again, now we're going to curve back to the pole, then up to pi, and hit that petal right there. Then back to the pole again, another negative value along 5 pi over 4 means now I'm up here in pi over 4 land. So again, curve back to the pole, cross up there, and we almost have our full shape. Back to the pole again, 3 pi over 2, we have a positive 6, so I'm right here. So curve down, cross the pole, continue down to that value, almost done, almost getting there. Cross that pole again, 7 pi over 4. Notice I'm negative, so I'm actually up here. And again, crossing back and hitting that right there. And oh my goodness, let's cross the pole one more time and then finish back where we started. So we'll curve down, cross the pole, and we will finish our lovely little rose curve. Now notice that our modifier was 4 and we ended up with 8 petals. That is the relationship for when you have an even n value. If we're talking about r equals b cosine of n theta, if n is even, you get double the number of petals. If n is even, you get 2n petals on your rose curve.